My name is Marcos, and there's Julio and Juan, and we're group 15. Today we're going to be solving this problem. So the problem states, consider a trapezoidal dam with length at the base of 50 meters and the length at the top of 60 meters and a depth of 20 meters, which essentially tells you the length of the trapezoid. And the water density is 90,000 newtons per meters cubed. Okay, so we broke down the dam. So since the base is 50 meters, we can tell that this part of the trapezoid is 50 meters, which tells us that the two bases for the triangles are 5 meters each. So since we know that, we can now tell how to solve the size, which Juan will tell you.
Okay, so having drawn the trapezoid, what we're looking for the force of each slice using this formula. So the force for the slice is the density of water times the height, which the height is right here, and times the area of the slice, which the area of the slice is a rectangle, so it's length times width. In order to solve for the length, we're going to have to use a proportion formula, because if we go, this right here is one of the triangles on the side here. Because the formula for length is length times width, and so this is the formula for each slice. Length is equal to 2a plus the 50, which is the man, that's not right.
Well, the thing is, this is the length for the entire two triangles put together. And what we're doing here is we're getting each triangle separate to figure out what the area of the triangle is. So we did a proportion to find the smaller triangle, so we get this part, correct?
So the problem with the formula here, I mean, once we solve for the length, the problem with it is that it's not in terms of h. We want everything in terms of h. So in order to get this in terms of h, we need to solve for the a here. In order to solve for a, this becomes a proportion. So then once we plug in all the numbers here, this is the a. So we plug the a back into the formula for length, and now we have it in terms of h. So then we can plug that back into the area for the slice, which becomes this right here. Once we have this, we can go ahead and solve for the force, which, again, we'll plug in all these numbers back into this formula, which the formula is right here. And then, knowing the force on each slice, then we can integrate from 0 to 20 to get the total force for the whole dam. And Julio will take over from here to show the calculation of the integral.
Solve for the area of the slice, we can go ahead and plug that back into our original force formula for that slice and end up with the formula of 9,800 times the height times negative 0.5 height plus 60 delta h, which is, when we plug into the integral, just dh, as you can see here. Pulling out that 9,800, we end up with 9,800 times the integral from 0 to 20 of h, negative h over 2, which is just 0.5, plus 60 dh. Then we use u substitution here. U is equal to negative half, negative h over 2 plus 60. Du is equal to negative 1/2 dh. But since there's clearly no negative 1/2 in here, as it's already been used here, we set dh equal to negative 2 du. And of course, we have to switch the bounds because just not to throw off our problem. So the lower bound, plug in for this formula, negative 0.5 times 0 plus 60 gives us 60. And the upper bound is negative 0.5 times 20 gives us 10 plus 60, negative 10 plus 60, 50. So we go ahead and plug those back into here along with the formula that we already solved for. So 39,200, which is just 9,800 cut in half, times the integral from 60 to 50 of u minus 60 u du. And here it's just already distributed. As you can see, the u becomes u squared and the 60 becomes 60u. Here we have to flip it, as it's going from 60 to 50 and we want it from 50 to 60. So it becomes negative 39,200 times the integral from 50 to 60, u squared, minus 60u du. Now that we have that, we can split the integral into two separate integrals. Negative 39,200 times the integral from 50 to 60 of u squared du, this initial portion, plus negative 60, as we pull that out, times negative 39,200, which is this, times the integral from 50 to 60 of u du. Now we just solved for the integral, and solving for a basic, x value type is quite simple. The integral of u squared becomes u to the third over 3 times our already constant, evaluated from 50 to 60, plus negative 60 times negative 39,200 divided by 2, which is, that 2 comes from the 1/2 u squared, evaluated from 50 to 60. And when you plug that into a calculator, you could actually work it out. But plugging it into a calculator, you get this answer, 1.045 times 10 to the 8 newtons. And that's how you solve this entire problem. Thank you.